Swayam Prabha. Digital India. Educated India.
So, hello student, today we will continue the model 2 sources, types and characterization of solid waste. So, in the previous class we talked about different sources and based upon the different type of solid waste. Now, today we will continue the same module based on sampling and characteristics of solid waste. So, this is most important discussion before discussion about collection, treatment or disposal, and characterization is very important, and along with the sampling also is very important. Like for water and wastewater, we need not to understand much about the sampling. Most of the students in the colleges, they take it the drinking water bottle for collection of water, wastewater, because it is a homogeneous most of the cases. And if you collect the water samples or even wastewater samples from different areas, I think most of these are homogeneous sampling and very easy to collect. But for solid waste is a highly heterogeneous waste. So, very difficult for the sampling as well as characterization. So, normally sampling we do by the quartering method. This method is given by NEERI, National Environmental Engineering Research Institute, Nagpur. This method called as a quartering method. So, normally sampling should be done in the 4 season, whatever the 4 season in the entire year. So, is a sampling itself is a very difficult for solid waste. If you want to understand the entire different type physical or chemical characteristics of the solid waste, need to collect sample from the 4 seasons, and normally in a week, entire 7 days, because weekdays and weekends are different way the waste is getting produced, and at least twice in a season. So, that the characterize sampling itself is a very difficult. If you locate, if you want to do the characterization study for the city, you locate out the different location, and this entire area also is segregated by high income group, low income group areas, commercial areas. These kind of different locations you can find it out, and in that location collect the waste. I give one example. Suppose 100 kg of waste, we put it like this, and now we will go for the quartering method. With the entire waste we will quarter in the 4 quarters, and these 2 quarters we will again put it in the same way, is a 15 kg waste, and likewise we will go by quartering the different waste, and we will get finally almost 10 to 20 kg of waste, that is a sample final. And from that the we will grind it, like this waste we will grind it, sieve it, and which will go for the chemical analysis, and final the same waste will go for the physical analysis. This is the way we can collect 10 to 20 or 15 kg of waste, that will be your sample. And the major idea about the quartering method is a need to get it the homogeneous waste, not heterogeneous waste. So, that and number of samples could go up to 10 to 30 different numbers of samples from the different locations. So, now first we will talk about the physical analysis, and after that chemical analysis. So, in physical analysis normally we do the composition analysis. We know that the waste is separated different physical properties such as dry, wet waste, how much amount of paper, plastic or different kind of waste is available. This normally this composition analysis we will do by manually, we will weight it and reference by the fractions of the total waste. This is very important for the selection and operation of the equipment, facility and disposal facility. Suppose without knowing the composition of different waste, physical composition like wet waste, very difficult to design the composting plant or biological treatment plant. And suppose if you are planning for the incineration facility, and if you do not know the how much amount of combustible matter, and majorly combustible matter like paper quantity, plastic quantity, rubber quantity, these very important combustible materials which required for the incineration facility. So, so for the not only treatment process but also for the disposal facility, need to know the how much amount of leachate is getting produced, or what kind of waste is available in the entire what kind of waste is coming to the disposal site. Based on that we can design the disposal facility. We will give one example. This is one study has been done in by the CPCB in 2000, municipal characteristic of few cities in India in 2000. If you see this entire data, you will see the paper and plastic quantity is very low. You see the plastic quantity was in 2000 was 3%, 2%, and very small quantity. Paper quantity is also at maximum 10%. But if you see the inert quantity and the biological quantity was more than 40%, 50% most of the cities, and even the inert content, which is not the dry and wet, is a different, the soil content, more soil content, that was the very high, was around 50%. If you see the another cities like the other cities also, like in Madras 10% paper quantity, plastic is only 3%, inert content is 33%, and biodegradable concentration was almost was more than 50%. But if you see in the this another report by the Planning Commission in 2014, if you compare with this data with the 2000, you will be surprised that the plastic quantity was very 3%, 1% was increase in the 2000 was more than 10%, and even the inert content was very high in 1996 or around 2000, what 45% was reduced to the only 17%, and but see the very surprisingly the biodegradable quantity was 42%, 47%, and even in 2011, 2014, 15, 42%. Still currently in 2020 also you see that the biodegradable fraction is almost 50%, and the paper and plastic quantity was increased to the 15 to 20%, and inert content was reduced to 30%, 35%. One more waste is added, construction and demolition waste. That quantity with the day, with the industrialization and developing into the city, that quantity is also increasing now. This composition variation is depend upon the different parameter, like first is the location. So, is the location wise what kind of a commercial activity in that particular location, and simply with the plain areas and hilly areas, these compositions, entire physical composition will change. Even in the warm and cold area, these physical compositions are getting changed. And the season, now that is why when I talked about the sampling, I said about that the sampling should be in the different season, because the season wise the entire waste or commercial facility, commercial materials also availability is different. So, the season also is one of the important parameter to know about the different composition of the solid waste. Now, another the economy. So, that is why when you do the sampling, I asked you about if you collect the sampling from the city area, we need to entire area has to be separate into the high income group, low income group, and commercial areas, market areas, vegetable markets, so that based on that with the time and with the economy is getting changed different waste compositions. So, it is very important to know about the waste composition. So, when you are planning for the sampling also need to be planned every after 10 years, 15 years, you need to do the sampling and to know about the different physical compositions are changing with the time. So, to design the recycling facility or any disposal facility. Now, the another parameter in the physical characterization is a specific weight or density. This very important to know about the how much volume. I think normally when you talked about the solid waste, we normally talked about in the weight, but the volume is also very important to know about how much area will be required into the disposal site. So that in the disposal site how many land will be required. For that we also need to know the what will be the density or the volume of the solid waste, and this specific weight or density is calculated by weight by volume. Normally in India or the developing countries have very high density waste that goes to 400 to 600 kg per meter cube, is because of inert content, more inert content, and more I also told about the construction and demolition waste. That is also because of that we are getting very high density of waste. So, if more density means your collection facility will be different based on that. This is one of the data for the specific weight values of the different Asian countries. Of mostly the Asian countries, if you see that the food waste, especially for the food waste, the density is very high. Likewise, for paper and plastic, the density is very low, like just 100 kg per meter cube. So, it is also changing with the different season, because the compositions are changing, the based on the composition density will also change. Another parameter called particle size. This parameter normally is important for the recycling facility, because there we need to know the what kind of size. Even for the degradation process also we need to know the particle size. There are different ways of calculation of particle size, like there are different ways by based on the length and width or height of that particular material. So, and these are the few machines normally or equipments we use to separate out the different size of the particle, like this is trommel, this is simply one of the another trommel screen, this is magnetic separator, like here once another magnetic separator. So, from that the magnetic particle is getting separated from the main waste. So, this is another physical parameter is the field capacity. This field capacity is the total amount of moisture that can be retained in the waste sample subject to the downward pull of gravity. This parameter is very important to know about the how much leachate is getting produced once the waste goes to the disposal site. So, is a excess of the water in excess of the field capacity will be released as leachate. Normally this analysis I think you can understand by this photograph. The solid waste, once the rain onto the disposal site will get the leachate production, that is called as the field capacity. So, I will show you some of the photographs. So, these are the leachate, is the leachate produced after the rain onto the solid waste. This is also one of the photograph where leachate. This normally if you know this quantity before the waste goes to the disposal site, will be able to design the collection facility and treatment facility of the leachate. Now, the chemical characteristics. This chemical characteristic is very important especially for the treatment process. Now, the first is the proximate analysis. Proximate analysis normally analyze to know about the combustion property of the solid waste to design the incineration facility or